Okay, so in this last section here, 16-9, we were talking a little about how hydrolysis occurs where you can either have an anion or a cation that has the ability to either be a acid or a base, which means you can kind of determine the pHs, rough pHs, based on what ions are present. So here in the first one, it says order the following from lowest to highest pH, so from most acidic to basic. Obviously, we're not going to get any numbers here, but in this case, here we are. So let's look at NaClO. So we know NaClO would break up into ions in solution like this, right? Where Na, it's just a metal from group 1, neither an acid or a base. It's negligible for either. But ClO4 definitely is a weak base, which means it could, react with a little water to generate some hydroxide ions. So this means the pH would start to increase on this one. So pH would be pretty high here, or at least higher than normal. Next one, KBr. So when this dissociates, it's ionic salt. You got K plus 1 and Br minus 1. K plus, again, a group 1 metal, neither negligible acid or base. Bromine, right? Bromine, as we talked about, so bromine can be attached to HBr, which is a very strong acid, but you guys know that the conjugate base to such a strong acid is essentially negligible. So this is that's a negligible base. So since you have neither here, this pH would be somewhat around 7, neutral, because neither one is acting as an acid or a base. And then number 3, this would break into 2 polyatomic, or 1 cation here, the ammonium ion, and ClO4 1 minus. So let's take care of NH4 first. So it comes from and stems from NH3, which we know is a weak base, ammonia. So when it accepts so we know a weak base, its conjugate acid would actually be weak. So this would be tend to be a weak acid, which means it can donate the H proton in solution, right? So it would donate it to water, and because it's a donor, the acidity starts to go down. Okay. ClO4, again, kind of similar to HBr, where it stems from, let's say, chloric acid, which is definitely one of those top 7. So this is a strong acid. So this, because this is the conjugate base of a strong acid, it's essentially negligible again. So ClO4 is not going to participate as being a base here at all. So if we put them in order, if we just review, we would say definitely choice 3 is definitely your lowest pH, since NH4 is a weak acid, followed by choice 2, which is KBr, because it has a pH of around 7, and then the highest pH, right, from highest to lowest in this case, is choice 1, NaClO, because ClO can accept the proton from H2O. So that's the order right there, 3, 2, 1.